And welcome to a new problem. The heading reads Magnetized spiral. And the statement of the problem being a plane helix with a large number of turns. Again, a problem, and an external radius r is placed in a homogeneous magnetic field that is normal to the helix's plane, okay, and varies according to the formula B equals B naught cos omega t. Find the EMF induced in the spiral. The distance between the adjacent turns is constant. This is a special problem. So let's start solving this problem by calculating the EMF induced in a single turn of the helix. And suppose the radius of this single turn of this ith turn is Ri, so that we can write induced EMF equals minus d phi I by dt. Obviously here d phi I is the change in magnetic flux through the area encircled by a turn during a short interval of time dt, and in a time varying field you can write time varying magnetic field, you can write the d phi by dt as simply as area of the turn, because we are concerned with the single turn, so area of the turn multiplied by dB by dt, that is same for all. And since B is equal to B naught cos omega t here, so dB by dt is going to be minus B naught omega sin omega t. And so EMF induced in a single turn can be written as minus sign cancelled out, B naught omega sin omega t SI, the area. But to calculate the total EMF induced in the spiral, we have to add each one of them, and that is going to be a problem, because when we try to sum up, we know B naught omega sin omega t is same for all, but their areas are different, because turns will have different radii and there are a large number of turns. So try to think something else at this moment. I tried it. If you like it, it's all right. Otherwise, show me a different procedure. I thought, let me first write add one more line to this solution. Induced EMF is equal to SI is by RI square. And considering the constant distance between turns, I think this pi Ri square is the volume, not the area, but the volume of a cylinder of unit length having radius Ri, so that its area will become, surface area is pi r square, and if the volume of the cylinder is of unit height, volume of the cylinder, if the height of the cylinder we can consider of unit height, its volume is going to be pi r square simply. Then I think summation of pi Ri square is the volume of such cylinders, and since the difference between the radii of adjacent cylinders is small, because the number of turns is large, the total volume of all these cylinders is approximately equal to the volume of a cone of volume of a cone you can see at your screen, of height say n. If there are if the number of turns we consider in this spiral being n, then it's definitely the height of this cone will be equal to n, and its base area will be pi r square, because the radius is r. And considering pi ri square not as a radius of some individual turn, but volume of a unit length of cylinder, we know that the total EMF induced is going to be 1 by 3 pi r square in the volume b naught omega sine omega t. And that is why I am proposing this solution like this, that the induced EMF is being 1 by 3 pi r square n b naught omega sine omega t, because simply pi r square b naught omega sine omega t is a wrong solution, I know. So it's going to be the solution, I think. Give me your angle on it. Thank you very much for watching.